Okay, hello everyone. Let us now discuss linear independence. It is important to know this concept because, as we will see later, the fundamental set of solutions for homogeneous equations is composed of functions that are linearly independent. Okay, so we will go through the definition and then we will do some examples. Okay, so let's define linear dependence or independence first. So a set of functions y1x, y2x until ynx is linearly dependent on the given interval I if there exists constants c1, c2 up until cn that are not all zero such that c1 multiplied by y of x plus c2 multiplied by y2 of x plus cn multiplied by yn of x is equal to 0. If, however, the only way to satisfy this equation is by letting all constants be equal to 0, then the set of functions are linearly independent. Okay, so let's to make this more concrete, let us apply it to examples. Okay, so let's try example 1. So we have here two functions. Y1 is equal to x and y2 is equal to 5x. So the problem is, how are we to determine if these two functions are linearly independent? Okay, so let's write down this equation here in the definition. So c1 multiplied by x plus c2 multiplied by 5x. Okay, so now the question is, can we find um, constant c1 and c2 such that this function is satisfied? Okay, the left hand side will be equal to 0 without setting c1 and c2 to 0. So if we can do that, then this is linearly dependent. So if we cannot do that, if the only way to satisfy this equation is by setting c1 and c2 to 0, then this two functions are linearly independent. Okay, so by observation, we can see that if we set c1 to c1 is equal to 5 and c2 is equal to negative 1. So what will we get? If we do that, we will get 5x minus 5x, right? Is equal to 0. So that would be 0. So that satisfied the equation. So the fact that we found these two constants right here that are not all 0, so therefore this first example, these two functions in the first example are linearly dependent. Okay, so that's it for the first example. So that was linearly dependent. Okay, let's go through another example. Let's go to another example. For the second one, we have y1 is equal to x and y2 is equal to x squared. Okay, so let's write the equation again. c1 x plus c2 and x squared this time is equal to 0. Now, can we find a certain c1 and c2 that are not all 0 that will satisfy the equation, just like in the first example? So the answer to that is no, right? Because this is x and this is x squared. Okay, so the only way that you can do this, you can satisfy this, is um, to set both constants to 0, right? So we cannot find constants other than setting both of these to 0 in order to satisfy the equation. So therefore, we can conclude Therefore, these two functions are linearly independent. Okay, so let's do the third example. So y1 is equal to x plus 5. And then y2 is equal to x. And then y3 is equal to 12. Okay, so through observation, can we satisfy this equation? C1 multiplied by x plus 5 plus C2 x plus C3 times 12 is equal to 0. So can we do that? Okay, so yes, we definitely can, right? Because as you see here, C1, we set C1 to 1, and then if we set C2 to -1, and then if we set C3 to be equal to -5 over 12, so what will we get? You will get x plus 5, then minus x, and then minus 5, right? So that will be equal to 0. Okay, so this is 0 is equal to 0. So the fact that we found constants other than setting them to all 0, therefore this is linearly dependent. Okay, so that's it for linear independence or dependence. So in the next lesson, there will be another technique in order to determine this, because functions can be complicated, and it's good to have another tool to confirm if it is indeed linear independent or dependent. Okay, so thank you for watching, and see you in the next video.